Jai, and today we are going to see the error control in the data link layer. So what is error control and why it is needed? If you remember, the layer below the data link layer is the physical layer. The physical layer is totally unreliable. It means that if we are sending any signal in the physical layer, there are high chances that in the signal some noise will be added. If some noise is added in the signal, the value of the signal will change. And if in the data, if one bit is changed, the whole data will be corrupted, and that's not what we want. So to control the error, this all functionality is provided in the data link layer, and in fact it is a responsibility of the data link layer to check if the received data contains any error or not. Generally, errors are divided into two types: the single bit error and the burst error. Single bit error, it means that if we are sending any data, only one bit will be changed, and in the burst more than one bits are changed. So you can see that in this example the sender wants to send some data. Now when this data is sent, because of the change in the signal at the physical layer, at the receiver side the value of the bit will change. So you can see that the highlighted bit is changed. So that is why it is known as a single bit error, because only one bit is changed. Now let's say the burst error. In the burst error, if we are sending any data, at the receiver side more than one bits are changed, right? So you can see that the sender is sending this data, at the receiver side more than one bits are changed, and when more than one bits are changed, they are known as burst error. You can see that the highlighted bits are changed, right? Now let's see how the receiver can detect the error. The receiver can detect the error using the redundancy concept. So the question is, what is redundancy? Redundancy means that if sender is sending any data, it will not send the data directly. Suppose if sender wants to send 8 bit of data, the sender will not send that 8 bit of data directly, but before that the sender will add some extra data to the original 8 bit data. Now why this extra data is needed? This extra data is needed because when this whole data, the 8 bit data and the extra data, is received by the receiver will be able to check the error using the extra data. So using the extra data, receiver will be able to check in the original 8 bit data if that original data contains any error or not. Are you getting it? So in this example you can see that the sender wants to send this datagram. This is our original data that sender want to send. Now sender will not send this data directly. Before sending this data, the sender will add some extra data. You can see that the sender has added some extra data. Now this original data with the extra data will be received by the receiver. Now when the receiver receives this original data with the extra data, the receiver will check for errors. So if no errors are detected, it will be delivered, but if any error is detected, the receiver will discard the data. So if no error, the data will be delivered to the destination, to the receiver. So there are some flaws in the redundancy method. Like the redundancy method is not 100% reliable. Why it is not 100% reliable? Because we are assuming that the error will be added in the original data, it will not be added in the extra data. So we are assuming that all the errors will be added to the original data, no error will be added in the extra data. But that is not possible in the real life scenario, right? Because in the real life, the error will be added in the both portion. So that is why the redundancy method is not 100% reliable. Now let's see the types of error detection methods. Generally, the error detections are divided into three types: the parity check, checksum, and the cyclic redundancy check. The parity check is further divided into two types: the longitudinal redundancy check or LRC and the vertical redundancy check, that is VRC. Now let's see this method one by one. Now we can see that in the VRC method we have some data to send. The length of the data that you can see is the 28 bit. So sender is interested to send 28 bit data. We know that we are not going to send this data directly. Before sending this data, we will do something, we will add some extra data, and after that we will send. In the VRC method, first of all, whatever data we are interested to send, it will be divided into blocks. Imagine right now the length of the block is 7 bit. So we will divide this data into 7 bit blocks. So how many blocks we will get? We will get 4 blocks. After that, we will add extra bit to each and every block depending on the parity. So in the VRC, either we can work on even parity or odd parity. In each and every block, we will add extra bit so that the total number of ones in every block can become either even or odd. Let's say example so that you will get the clear idea. We will divide this data into block and each block is having 7 bit. So you can see that this is the first block, and in the first block we have added extra bit. Now this extra bit is added so that the total number of ones in the block becomes even, because already there were odd number of ones and we have added one more bit, so the total number of ones have become even. So in each and every block we will add extra bit so that the total number of ones can become even. Why we are doing so? Because right now we are working on even parity. If we were working on odd parity, so we will add extra bit so that the total number of ones in each block becomes odd. In the second block, we will add 0. Now why we are adding 0? Because the total number of ones are already even. In the third block, we will add 0. In the fourth block, we will add 0. After adding one bit to each and every block, we will combine this block and we will send. So you can see that we have combined and we have sent to the receiver. Now receiver will follow the same procedure. The receiver will divide the data, and after dividing, the receiver will add extra data to each and every block. So receiver will again check the number of ones. Now in the first block you can see that the total number of ones are already even, so receiver will add 0. In the second block again even, in the third again even, and in the fourth again even. So you can see that at the receiver side every added bit has 0 value. Every bit that we have added is 0 bit. So in the vertical redundancy check, if all the extra added bit is 0, it means there is no error, and if we are getting any value apart from 0, it means there will be some error. Now let's see this situation in which there are some error. Okay, so we can see that we are following the same method, that we have divided the data into block, and in each block we have added some bits and we have sent to the receiver. Now imagine in the channel one bit is changed. So if one bit is changed, we can see that the every added extra bit is not 0, is supposed to be 0, but if receiver is adding extra bit and the value of the bit is non-zero, any of the bit is non-zero, it means there is some error. And in fact we can also find the block in which the error is present. Like we are getting 1 here, it means in this block there is some error. There is some limitation in this method. Right now we are assuming that only one bit is changed, but imagine if 2 bits are changed simultaneously, then we will be getting 0 here. So in that case we won't be able to get any error. Now let's see the second method, that is the LRC, which is longitudinal redundancy check. Now we are seeing the same example, that right now the sender want to send 28 bit of data. We know that the sender will not send this data directly. Before sending this 28 bit of data, the sender will divide this data into blocks. Now length of block is variable. We are assuming that right now the length of block is 7 bit. So we will get 4 blocks. After dividing the data into block, it will arrange in this form. Now in the longitudinal redundancy check, what the sender will do is that it will check each and every column. It will check total number of ones in each and every column, and after checking total number of ones in each and every column, it will add extra bit at the end of every column. An extra bit will be added in such a way that total number of ones will become even. Okay, so we will check the first column. In the first column, if the total number of ones are even, so we will add 0. In the second column, total number of ones are odd, so we will add 1 here. In the third column, total number of ones are even, so we will add 0 at the end of the column. So likewise we will perform this, and after that we will send the original data along with the extra data. So you can see that this is our original data, the 28-bit and the extra data that we have got by adding extra bit at each and every column. At the receiver side, it will arrange this data in the table form, and at the receiver side it will perform the same method. So receiver will add extra bit to each and every column, and after adding the extra bit, if at the end of the column if we are getting all the zeros, it means there won't be any error. There is no error. The receiver has received the data successfully and the received data contains no error. So this is how the longitudinal redundancy check works. Now the remaining methods will be discussed in the next session. So thank you so much.